Hey guys, welcome back to another GCSE Maths video. This time we're approaching the first paper. As of recording this, is about 38 days away. When it uploads, it's probably close to 30 days away. And I figured that this would be a really good time for me to go through the 2024 paper 1 that they did in June, which is obviously the most recent set of exams. Technically there are November papers as well, which I might do closer to the time, but this would be a really good time for me to walk through the non-calculator paper 1 2024. Now, in the description or in the kind of chapters of this video, I have just separated it into the different questions. So I'll say question 1, 2, 3, so you can skip ahead or skip to whatever questions you find relevant. I'm willing to bet some of you have done this paper before in terms of as a mock, so it'll be a good time for me to go through some of the harder questions on it. The other thing I wanted to show you is the grade boundaries. These are the grade boundaries for this exact exam that we're doing, and I put it as a percentage because of course I'm not doing all 3 papers in this video. I'll do all 3 papers over time, but as we go along you can always try and do the questions alongside me and use the video as a mark scheme. So when I go to question 1, you try and do it, then you check your answer, and you can kind of see roughly where you're going to get. So if you take however many marks you get, divide it by 80 times by 100 to get your percentage, you can see roughly what grade you would have gotten if you did this exam last year. So without further ado, again, check the chapters in the video for whichever question that you might want to be stuck with, but let's get started right now. So here we have question 1. Here are the first 4 terms of an arithmetic series. Find an expression in terms of n for the nth term of the sequence. Now, the way I do this is I write out this series, and all I do is I write out the difference. So 5 minus 1, it adds 4, add 4, and add 4. So it's adding 4 every single time. That means we're going to write 4n. Now there are a couple of different methods to in terms of what you would do next. What I would do is I would go back to find the 0th term, so the term before the first term, which gives me -3, which means my answer is 4n take away 3. Now again, there are other ways to do that, but that's the method that I personally prefer. For question 2, we have to subtract mixed numbers. Remember, this is a non-calculator paper. My recommendation is to turn them into improper fractions first, which you do get a mark for. So 3 times 5 gives me 15, add 4 is 19, so we have 19 over 5, take away 1 times 3 is 3, add 2 is 5, over 3. Then all we need to do is make the denominators the same. So the quickest way to do this is to just times them by each other. So I can times the first fraction by 3, the second fraction by 5. That will give me 19 times 3. You could do 20 times 3, which is 60, and then minus 3. That could be one way to do it. Or again, you can always use the column method on the side. Over 15, take away 15, not 15, 25. Over 15. Then we can actually subtract. So 57 minus 25 is 32 over 15. Remember that you only subtract or add the numerators when you're adding or subtracting fractions. Now, technically speaking, they didn't specify to leave it as an improper fraction or mixed number. What tends to be the case is that if they give it to you as a mixed number, you should give it as a mixed number. But again, you get marks for both of these on the exam. In order to turn it back into a mixed number, you say how many times does 15 go into 32? Well, 15, 32, 45 is too big, so it only goes in twice. And then there's 2 remainder. And that would be it for part A. Kevin was asked to work out a mixed number, 2 1/3, times 5 over 8. Here is his working and his answer. His answer's wrong. What mistake has he made? In questions like this, the best piece of advice I can give you is to do the question yourself. Do it line by line. So what he does is you'd have to change it to an improper fraction first. So 2 times 3 is 6, plus 1 is 7. So we get 7 over 3 times 5 over 8. So far we've gotten the same thing, so that step's correct. Then when we actually do the 7 times 5 and the 3 times 8, we would get 7 times 5 is 35, 3 times 8 is 24. So again, that's correct. So if I turn this into a mixed number, 24 goes into 35 once, right? Because 24, then it'd be 48. And then what's the remainder? Well, 35 minus 24 is 11. So it should be 11 over 24. So simply put, it should be 11 over 24 instead of 9 over 24. That's the mistake he made. And again, that's probably the best process, the guaranteed way of working out what mistakes people have made. So for question 3, we have a diagram showing the plan of a floor. Petra is going to cover it with paint. She has 3 tins of paint, so I might start highlighting this. So 3 tins of paint, 2.5 litres per tin. 1 litre covers 10 square metres. Assuming she's correct, does she have enough paint to cover the floor? So what's the logic behind this question? Well, first of all, we need to work out what area she can cover. So if she has 3 tins of paint, and there are 2.5 litres of paint in each tin, then that means she has 3 times 2.5. She has 7.5 litres of paint. And how much will that cover? Well, 1 litre covers 10 square metres. So all we need to do is, if we write 1 litre equals 10 metres squared, then 7.5 litres, all I'm doing is I'm timesing by 7.5. And 10 times 7.5 is, of course, 75 square metres. So she can cover 75 square metres of area. Okay, that gets me a couple of marks. We now need to work out what is the area of the actual thing she's painting. Now, here, if we look at this, we don't know how to work out the area of this kind of shape because it's an irregular shape, right? It's not a normal one. It's not one of the ones we know. It's a compound shape. So what I would do is I'd cut it into 2 rectangles. So the first one is this. We have 8 times 6, which is nice and easy. So 8 times 6, which is of course 48 square meters. Now this one's a bit trickier. It's not 5 times 10. It's 5, the height, times the width. Now the width here is going to be the full width of the shape 10 minus the 6 meters here, right? Because it's like it's been cut off. So if I write that that's 4 meters, hopefully that makes sense. The full width is 10, that much is 6, so that much must be 4. And 5 times 4 is, of course, 20 square meters, which means the total area is 48 plus 20, wasn't it? Yeah, 48 plus 20, which is 68 square meters. Now, does she have enough paint? Well, she has enough paint to cover 75 square meters, and the floor is only 68 square meters. So, since 68 is less than 75, she can, or she has enough paint. Now, one point that I tell a lot of my grade 9 students is don't waste marks. You get a mark for the conclusion. You have to write that she has enough paint. You have to. Now, here's the other thing. You can't just guess yes or no. Let's say you didn't have to do this question, you just wrote yes or you wrote no. You would get 0 marks. In the mark scheme, it specifically says yes, supported. So there needs to be some maths, some numbers that support your conclusion. So just be careful with that. Now that's part A. Part B says 1 litre actually covers 11 square metres. Does it affect your answer to part A? Now, here's another thing. When I see people answer this question, some students, where it says, does this affect your answer? They'll say, well, of course it does, because it changes how much paint what area she can cover. That's not the answer. What was the actual answer to this question? It wasn't 68. That's not the answer. It wasn't 75. The answer was yes, she has enough paint. So when they say, does it affect your answer? They're saying, does it change the fact that she has enough paint? That's what they're asking. They're not asking for any of the numbers. They're asking for, is the answer different? The answer being yes in this case. So, if 1 litre covers 11 square metres, where did we use that? Well, we used that over here. We said 1 litre equals 10 square metres, so now it would be 11. And then what we'd do is we'd times that by 7.5, right? And then whatever that is, well, actually I can work out what that is. It would be 82.5. Yeah. But anyways, does that matter? Well, no. Because that means she would have even more paint than she needs. So she'll still have enough paint. So does it affect your answer? No. That doesn't give you any marks. You must give a reason. It just means she has even more paint than she needs. It just means she will need less paint or something like that. So she already has enough paint. right? Something like that. So either she'll need even less paint, she still has enough paint, it will now cover 82.5 square meters, something along those lines, anything like that. But be really careful with the way you answer these questions. You don't want to lose silly marks. This question was remarkably poorly answered, although it's actually not that remarkable because I understand set notation is something that students find a little tricky. A lot of the year 12s and even some year 13s can find set notation tricky, so I don't blame you if you weren't too sure. So we have a Venn diagram, it has a bunch of numbers in it, and they separate it into P and Q and then everything else. So it says write down the numbers that are in set P apostrophe. So what does that mean? I read it as P not, i.e. the apostrophe means not P. It's like it inverts it. So if I asked you what are the numbers in set P, you would look at the P circle and you would say, okay, the numbers in set P are 12, 15 and 18, and you'd be correct because all of those numbers are inside P. But when it says not P, you're looking for everything that is not in P, which is 10, 14, 11, 13, 16 and 17. If you'd like, I could scribble out those numbers and it's just every other number that you can see. Cool. Now, what about this thing here? Now, your teachers might have called this P union Q, something like that. I like to think of it as P or Q. So find the probability that the number is in the set P or Q. So if I pick one of these numbers, how likely is it that I pick a number that's inside one of these two circles? Well, again, here's what I do. If it's P or Q, it means we're looking at everything inside these two circles. Now, how many numbers are inside those two circles? 1, 2, 3, 4, 5. So it means the probability is going to be 5 out of the total number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 out of 9. So I know that might not seem too tricky, but in exam conditions, I can imagine people making a lot of mistakes, which I get. And also set notation is not something people are super confident on, to be honest. With this question, we have Sophie drives a distance of 513 kilometers. So again, I'm going to highlight those numbers. She pays 0.8 euros for every 10 kilometers she drives. So again, making sure that we highlight the key information because remember, they will not give you information you do not need. It then says work out an estimate, and that's a really key word, estimate, for the total amount that she pays. The reason why I say that that's a really key word is if I work this out manually and I get the answer exactly right, I will get 0 marks. You have to round in order to get the marks here, because otherwise it's not an estimate, which means you haven't done an estimate. So if you do no rounding whatsoever, you get 0 out of 3, even if you get the answer completely right. So if I use a calculator right now, get the exact right answer, even if I did it by hand, I get 0. So when we're rounding, I always recommend to round everything to one significant figure. So that becomes 500 kilometers, that obviously stays 10 kilometers, and that goes to 0.8 euros. So how do we work out the total amount that she pays? Well, she pays 0.8 euros every 10 kilometers, and we have 500 kilometers. So that means she has to do 500 divided by 10. She has to pay 50 times. Then we need to do 50 times 0.8. And I think doing this in terms of a fraction might make a lot more sense, because then what we could do is we could divide by 10 and just get 5 times 8, which is 40 euros. And of course they give you a range of values because you can round to other amounts. You don't have to round to 1SF. It's just that 1SF will always work, and that generally makes the numbers super easy. For part B, it says, is your answer an under or over estimate? So basically, is my answer too big or too small? Well, if I look at this, I rounded down the number of kilometers that she drove, which means she should actually have to pay more money, right? We also rounded 0.81 euros down to 0.8 euros, which means, again, it's cheaper than expected. If it's cheaper than expected or cheaper than it should be, then that means it is an underestimate. So underestimate, because we rounded down, as we rounded down. And that's it for question number 5. For number 6, we have a straight line drawn on a grid and we have to find an equation for the line. So remember, equation of any line is y equals mx plus c. And so the two things we need to find out are c and m. Now m is the gradient, it's how steep the graph is, and c is the y-intercept, so where it intersects the y-axis. So I already know, I can see just from looking at the graph, that c is going to equal 3 because it intersects the axis at 3. Now in terms of the gradient, that's a little bit different. There's loads of different ways you could do this. You could just take 2 points that go through the corner of a box and work out the gradient from there. Or you could do it in terms of coordinates. But the way I like to do it, if I can, is doing it this way, where I can do the, not the steepness, the height divided by the width. So the equation of this line, for 3 marks by the way, is just y equals 3 over 2x plus 3. So this is definitely a topic you should practice because that is just beautiful. It took me, what, 30-45 seconds? However, this is slightly trickier. Well, not trickier, it's easy to make a mistake. M is a different straight line with the equation y equals 5x. Write down the equation of a straight line. So when it says that, it's not a specific line they're talking about. It's any line that is parallel to M. First of all, what does parallel mean? It means it has the same gradient. So that's the number in front of x, which means I know that my equation for a parallel line will also be 5x because they both have a gradient of 5. Now here's where things get interesting. All you need to do is write plus or minus any number that isn't 0. Because every single equation, so it could be plus 3, it could be minus 10, it could be plus 4.5, it could be minus that number, it could be anything. Because any of these lines will be parallel to y equals 5x because they all have the same gradient. Kasim has some small, medium and large jars and he has a total of 400. 3/8 are empty. For the empty jars, we have a ratio for small to medium and also medium to large. Work out the percentage of Kasim's jars that are empty small jars. So what are we trying to work out here? Well, if I start again from the end, work out the percentage that are empty jars. So we need to work out the number of empty small jars over the total number of jars, which is 400, and then times by 100, right, to make it a percentage. Right, that's how you do percentages, right? You take the number that you are interested in out of the total times by 100. So all I need to do is work out how many empty small jars he has. When we have a look at these jars, they're split up in a few different ways. So first of all, we have all jars, then there's going to be the filled ones, and the empty ones. And then the empty ones are broken up into 3 pieces. Small, medium and large. And we are interested in the number of small empty jars. So let's try and work out some of these values, shall we? Well, 3/8 of the 400 jars are empty. So if we do 3/8 of 400, well, that's 400 divided by 8. There's loads of different ways you can do that. What am I doing? Divided by 8, you could half it 3 times. You could also do 40 divided by 8, which is 5, and then add a 0. So we can do 40 divided by 8, then add the 0 back on. Anything like that. And then we're going to do 50 times 3, which gives us 150. So there's 150 empty jars. Now, we have a ratio for small, medium and large. And we know that small to medium is 3 to 4. Medium to large is 1 to 2. So we need to combine this ratio. How do you combine ratios? Well, you look for the common letter, in this case m, and you make the number associated with m the same. So we have 4 and we have 1. So if I just times this right-hand ratio by 4, then all of a sudden they'll all have the same number, which means we can combine the ratio as 3 to 4 to 8. Beautiful. So now if we're working out the number of small jars, well, if we add these numbers up, 3 plus 4 is 7, plus 8 is 15. We are sharing 150 empty jars into 15 equal parts. So 15 parts equals 150. 1 part equals 10. We are interested in the number of small jars, so small gets 3 parts. So therefore we have 30 small jars. Going back to our original equation, number of empty small jars over 400, so we have 30 over 400 times 100. What I would probably do is I'll probably be a bit cheeky and then cancel out the zeros. So we just have 30 over 4. In terms of dividing that, we can simplify it to 15 over 2. Then you can use bus stop method if you need to work out the actual percentage. So that's 0, it's 1, 15 divided by that will be 7, remainder 1. So we have to put a decimal point. So 7.5%. Really nice for 5 marks if you can lay your work out and you break it down nice and easily. Len has 8 parcels. The mean weight of the 8 parcels is 2.5 kilos. The mean weight of 3 of the parcels is 2 kilos. Work out the mean weight of the other 5 parcels I can count. So if you remember, mean will be, in this case, total weight over the number of parcels. So if we have 8 parcels, 1, 2, 3, 4, 5, 6, 7, 8. The mean of all of these is 2.5 kilos. So from that, because the mean is the total weight over the number, I could work out the total weight of all 8 parcels. 2.5 times 8, which if we double it, that's 16. Add on half again, that'd be 20 kilos. So you might be wondering why I'm doing this. Well, it's because they tell me that the mean weight of 3 of the parcels is 2 kilos. And our objective is to work out the mean of the other 5 parcels. So if we look back at our formula, we need to work out the total weight of the 5 parcels and divide it by 5. So they've given us the mean of all of the parcels and we've worked out the total weight of all 8. So if I work out the total weight of these 3, subtract it from the total weight of all of them, then I have the total weight of the 5 that are left over. So let's do the total for the green. That equals 3 times 2, 6 kg, which means for the total for the black is just those 2 subtracted, 14 kilos, which means the mean is 14 over 5, which again you can use let's say use a calculator. You can use the bus stop method to work it out. It should be, again, if we do it, 5 into 1 is 0, 5 into 14 is 2, remainder 4, so let's put a decimal point. 5 into 40 makes 8, so that's 2.8 kilos for 3 marks. Not too shabby. In a sale, the normal price of a coat is reduced by R%. Given that the sale price is 0.7 times the normal price, find the value of R. So I know some people don't like using multipliers for percentage change, but this just shows you it is required knowledge. And it does make your life easier. Now, here's the logic. When we reduce something in a sale, 100% is the original price. Then we go down to whatever percent, depending on what the sale is. If it's a 10% sale, we go down to 90%. If it's a 30% sale, we go down to 70% and so on. In this case, 0.7 as a percentage is 70%. So this must have been a 30% decrease, which means R is just equal to 30 because we have to do 0.7 times the normal price. Solving simultaneous equations, a classic question. It will come up, it's guaranteed, on paper 1, 2 or 3. I would suspect paper 1, but solving these equations is very important, especially if you want to do A-level maths, you'll be solving simultaneous equations constantly. So what's the method here? Well, you want to make either x or y the same, so you can add or subtract the equations. What do I want to do? I'm going to make x the same. So if I times the first equation by 5 and the second equation by, sorry, not by 5, times the first equation by 2 and the second equation by 5, then I can write it as this. So 5x times 2 is 10x, minus 2y times 2 is minus 4y, 23 times 2 is 46. 2x times 5, 10x, minus 3y times 5, minus 15y. 18 times 5, well 5 times 10 is 50, 8 times 5 is 40, so that should be 90. And then all we need to do is subtract these two equations in order to get our value. So 10x minus 10x is 0. If you're ever wondering why we make them the same, and then if you're not sure if you need to add or subtract, when we subtract here, the reason why I know we subtract is if I subtract, the x's go away. If I were to add, x and y would still be in the equation, which means I've done something wrong. But another way to think of it is same sign subtract, different sign add. So these have the same sign in front, they're both positive, so we subtract. Minus 4y minus 15y is 11y. 46 minus 90 would be minus 44, which means y is equal to minus 4. Then we just sub this back into an equation. Which one would be good? Let's just say the top one, to find the value of x. So we have 5x minus 2 minus 4 equals 23. I've written out everything, if you've noticed, including the substitution, because again, another common mistake that I see students make is when they sub it back in, they don't include the minus on the outside of the bracket. So they would probably write minus 8, for example. Well, no, it's actually 5x plus 8 equals 23. So be careful with that. Minus 8 from both sides gives me 5x equals 15, which means x is equal to 3. So our two answers are minus 4 and 3. And again, for 4 marks, you could do that really quickly and efficiently. But again, write down your steps. Not only will you guarantee the method marks, you'll also decrease the likelihood of you making a silly mistake. So yeah, this one's going to be a little tricky for me to do on the old computer, but I'm going to try and explain to you how to do that. But here it says triangle A is translated by 6 minus 4. Remember, the top number tells you how many to the right you're going. The bottom number tells you how many upwards you're going. So if it's 6 to the right, minus 4 upwards means you're actually going down. So it's going to be each point here goes 6 to the right. 1, 2, 3, 4, 5, 6. Then 4 down. 1, 2, 3, 4. From here, you don't actually need to do this with every point, because I can see that the shape isn't going to change. So it's still 1 wide. It's still 2 tall. And that would be my triangle B. Now, it then says it's rotated clockwise. A little bit tricky for me to do on the computer, not going to lie. But let me describe to you how you would do this in the exam. You would get your big piece of tracing paper. This is something that should be provided to you. So if you don't have some in the exam hall, make sure you ask, because you're entitled to it. And I've just realised that's actually too low. No, hold on. Please. Okay. Well, anyways. What you do is you sketch or trace this shape. You put your pencil on the 2, 1. And you're going to turn it clockwise. So think about how a clock goes. In this case, it'd be going this way. 1 turn. So this edge will be down here. This edge will be over here. And then you draw the exact same shape that you see. And there you go. The dreaded graph matching exercise. Now I'm kidding. I think this is fairly well answered most years. There are a lot of graphs here, and some of them scare some students. Like, some of these look a bit wonky. Don't forget, we only need to pick 3 of them. So most of these graphs are completely irrelevant. So let's start with the first one. Look at what type of graph it is. The type of graph is determined by what's happening to x. That's what tells you what type of graph it is. So this is x squared. So it's either a happy face or a sad face. Because it's a positive x squared, it's a happy face. Positive means happy, right? So if we look for a U-shaped graph, the only 2 we have are A and H, but A is a sad face. So H is the only answer. There you go. What about the x cubed? Okay, well, x cubed, this depends on how well you actually know your graph shapes, but x cubed looks like half of a DNA strand, you know, like this. However, this is a negative x cubed, which actually goes the other way. So it's like the other half of the DNA strand. So in this case, it would be f. Now, is there a way to work this out in the exam if you completely don't know what you're doing? Yes. Here's how you do it. Assuming you could narrow it down to one of these two, you could simply sub in values. So when it's negative, if it's a negative x cubed graph, what happens if I sub in a negative number? Well, minus 1 cubed is still minus 1, so it's minus 1, which is plus 1, which means it starts from the positive side instead of the negative side. Whereas if you sub in a positive number, you would get a negative result. So that's the only way you can really tell from that. Here, 5 over x, well, the 1 over x graph, again, normally looks like this, but this is a negative 5 over x, which means it's flipped. So instead, it should be something that looks like the red one. So if we look for the one that looks like that, it's going to be J. Again, it's a little tricky, but definitely make sure you practice learning your graphs because some of these are not really that bad and they're 3 marks just on the table. So, drawing a histogram. Honestly, I don't think drawing a histogram is too tricky for a lot of students. It's getting confused between histograms, frequency polygons, frequency diagrams, cumulative frequency diagrams, things like that. That's what normally gets students to lose marks. So, in terms of the histogram, it's the one that looks like a bar chart, right? Where you have to work out the frequency density by doing the frequency divided by the class width. So 20 divided by the width, that's 10, right? It goes from 0 to 10, difference of 10. 20 divided by 10 is 2. That would be 70 divided by 20, which is 7 over 2, which is 3.5. Then it's 22 over 5. Yeah, great, that's a lovely number to pick. So that goes in 4 times remainder 2/5. So that's 4.4. That's 30 over 15. That's lovely. That's 2. That's 8 over 10, which is lovely. It's 0.8. Then on your y-axis is frequency density. And on your x-axis is whatever this is. So the time in minutes. And yeah, the first thing we need to do is work out what we should go up in. So we need to go from 0 all the way up to 4.5, let's call it. So let's count how many big squares we have. We have 1, 2, 3, 4, 5. So we can actually go up in ones, which is super nice. That is beautiful. And along our x-axis, we need to go from 0 to 60. How many boxes do we have? We have 1, 2, 3, 4, 5, 6. So we could go up in tens, which again is lovely. 30, 40, 50, and 60. So again, this is the one that looks similar to a a bar chart. So from 0 and 10, we're going to go up to 2. So essentially, you draw the bar coming off of the y-axis up until 10. You draw it coming down. Ooh, that looks nice. Then the next one's 10 to 30. So remember, you're continuing from this bar. You're not leaving a gap. It's from 10, so it's on this bar. Then that's 3.5. So that's all the way up here. What does that go up to again? 30. Alright, so that goes along. Then it goes down. By the way, use a ruler. I'm being a bit naughty. 30 to 35 is 4.4. So again, that's going up to like that part there. 4.4. So this goes up in 0.1s because I made the gap equal to 1. So it goes up by 1 in 10 squares. So each square is 0.1. So 0.4 is 1, 2, 3, 4. Again, try your best to make this a... When it gets towards the end, that's when my hand starts cramping. There we are. Then we have 35 to 50 goes up to 2. That's nice. It's only up to here. And let's go across. I'd have been a terrible surgeon, you know that. I'd have been cutting people up. 50 to 60 goes up to 0.8, so it's 2 below. And there you have it. Beautiful. So in terms of where you get your marks, axes labelled and with a scale. 4 correct marks and... 4 correct bars, then you're done. That's it. Now it says, work out an estimate for the fraction of these people, these 150 people who are in the shop for between 20 and 40 minutes. So why are they saying an estimate? Well, if you notice, 20 to 40 is not a full bar. So instead, 20 to 40 involves this area. It involves this area. And it involves up to here. So, why did I say area? Well, if you remember, the important thing about a histogram is the area of the bar is proportional, or in this case is equal to, the number of people inside it. So for example, if I wanted to work out how many people were between 0 and 10, I could do 2 times 10, which is 20. Right? So it works. So if we want to estimate this, if we work out the area of each of these bars, we can just add them up. So let's write 1, 2, and 3. So the area of 1 is the width of 10 goes up to 3.5. So 10 times 3.5, which is of course 35. Area of 2, well, we actually know the area of 2 because it's just the 30 to 35, it's going to be 22. But if you wanted to, it's 4.4 times 10, times 5. So that's going to be 22, we already know that one. And 3, we have a width of 5 and a height of 2. And 5 times 2, you might be shocked, is 10. Add them all up and we are done. Well, don't forget we have to do a fraction, but add them up. 35 plus 22 is 57, plus 10 is 67. So our fraction is 67 out of the total number of people, which is 150. There we go, that's the fraction of these people. If they said what's the probability that they took between 20 and 40 minutes, our answer would actually be the exact same. So that's just a fun fact for you. Oh boy, here we go. Triple brackets. Probably some of the harshest marks you'll ever see because it's only 3 marks. Same with algebraic fractions, normally only 3 marks. It's harsh. It is harsh. But what's the method? Expand 2 at a time. So I'm going to expand these first 2 brackets first. So 3x times 2x, 3 times 2 is 6, x times x is x squared. 3x times 3, 9x. Minus 1 times 2x, minus 2x, minus 1 times 3, minus 3. Remember, it's 3 marks, so you have 3 minutes. So take your time. 180 seconds is a long time. Then I would simplify. And then I immediately don't simplify. And now we need to expand again, but this is weird because technically we haven't expanded 3, a trinomial, with a binomial. So a 3-term bracket with a 2-term bracket. But don't worry. All you need to is remember everything in this bracket times everything in this bracket. So start with the 6x squared. 6x squared times x is 6x cubed. 6x squared times minus 5. So 6 times minus 5 is minus 30x squared. Then the next one, 7x times x, 7x squared. 7x times minus 5, minus 35x. And lastly, but certainly not least, minus 3 times x is minus 3x. Minus 3 times minus 5 is plus 15. Gathering all the like terms, so we have 6x cubed. That's the only x cubed, so I'm done with that. With the squareds, we have minus 30x squared plus 7x squared. So we have minus 23x squared. Then we have minus 35x minus 3x. That's minus 38x. Then a plus 15. There we go. Again, that took me less than 180 seconds, less than 3 minutes, because I took my time. Do not rush this. Rushing will kill you. It will get you. You'll just lose marks for no reason. Take your time with it. OAB is a sector of a circle with a centre O, radius 6, cool. Length of the arc is 5 pi. Work out the area of the sector. So again, I stress this all the time, it might be getting annoying, they will not give you information you don't need. So this is useful information. And why is that? Well, to work out the area of the sector, you have to do theta, the angle here, over 360 times the area of a circle, right? Because a sector is just a fraction of a circle. So what's the problem? Well, I don't know what the angle is. I only know what the radius is. And while that's useful, I need the angle. That's why they give me the length of the arc. Because what's the length of the arc? Well, it's still theta over 360 times the circumference of a circle, 2 pi r. And we know that that equals 5 pi. So let's sub in the stuff now. Well, the first thing I'm going to do actually is I'm going to cancel out the pi's. Because I'm just cool like that, you know. 360 times 6 equals 5. How do I want to do this? Well, let's actually just simplify it as a fraction. If I divide the top and bottom by 6, I get theta over 60 equals 5. So that means the angle is 5 times 60, which is 300. Yeah, that could work. I don't see why not. Before we do that, there was a times by 2. So that's meant to be a 12. There we go. And then that should be, if we divide top and bottom by, what could we divide it by? We could divide it by 4. We could divide it by 12 still. That would give me 30. There you go. Okay. That's why you don't rush. There we go. Now we can sub into the area of a sector formula. So pi, and what's the radius? It was 6, just 6 squared. Now, how do I want to do this? It says leave it in terms of pi. So what I might do is I will divide the top and bottom of this fraction by 10. So I get 15 over 36 times 6 squared is also 36 pi. So now I can cancel out those 36's and I'm left with 15 pi. Not too bad. And that's a 4-mark question? Yeah. It's pretty good for 4 marks, not bad. There are only n orange sweets and 1 white sweet in a bag. Sarah takes at random a sweet from the bag and eats the sweet. She then takes another one and eats the sweet. Show that the probability she eats 2 orange sweets is n minus 1 over n plus 1. Well, the first thing we need to keep in mind is that if there's n orange sweets and 1 white sweet, the total initially is n plus 1. So what's the probability of her taking 1 orange sweet? Well, it'll be n over n plus 1, right? Because there's n orange sweets, there's n plus 1 sweets in total. Then she takes another orange sweet, so that's and, so we're going to do times. Well, how many orange sweets are left? Well, there's n minus 1, right? Because let's say n was 5. If you eat 1 sweet, there's 4 left. If there was 10 orange sweets, you eat 1, there's 9 left. So it's minus 1 of those left. Over n plus 1 minus 1, so over n. You could cross cancel here, by the way. And that'd be totally fine. But it gives you n minus 1 over n plus 1. Nice. If you didn't like that, you could have it like this. And just divide top and bottom by n to get the exact same result. So whichever way works for you. A little bit of cheeky surds action. So when you rationalize the denominator, you need to get rid of the surd in the denominator. The way you do that, if there's just one item, one term in the denominator, is you times by itself. Because root 7 times root 7 will become 7. So in other words, it gets rid of the denominator. So that would be 1 times root 7 is root 7 over 7. For part B, simplifying, when you simplify surds, you break down the number into 2 numbers that ideally, well, A, they need to multiply to 80, but ideally one of them is a square number. Now, because they're saying simplify, I'm willing to bet that I can break this down into 5 times something, because this is already 5. Okay, 5 times what gives me 80? Well, 80 divided by 5 is 16. So I could break that into 16 times 5 minus root 5. So that's root 16 root 5 minus root 5. Root 16 is 4. So 4 root 5 minus root 5 is, so how many root 5s do I have left? I have 3 root 5s left over. So remember, you can subtract them as if they're x's, like 4x minus x is 3x. Well, this is fun. So it's a recurring decimal question, shockingly. However, you have to do 2 recurring decimals and you only get 3 marks. What the hell? So yeah, that's not that's not nice, is it? But we have to turn these both into fractions. And again, there's no real getting around it. We just have to do the legwork for this. On the bright side, they're not too bad. So if we say x equals 0.151515, what I do is I times it by 10, well, with 1, and then the number of zeros is just the number of recurring decimals. So in this case, we have 2 recurring decimals, so I'm going to times it by 100. The reason is that ensures that, well, let me show you. 15.151515. It ensures that those decimals line up properly. And when they line up, it means that they'll cancel out. So all of these 15s will cancel out. So if we do 99x, we get 15 minus 0 is obviously 15. Then we get 1 minus 1, 5 minus 5, 1 minus 1, 5 minus 5, and so on. So 99x is just 15. So x is just 15 over 99. Very good. We can do the same thing. I might call it y instead for 0.2272727 going on forever. Now again, we could use 100y for this. Why? Because there's 2 repeating digits. And that would give me 22.7272727. So the way I like to do this, I like to lay it out in a way that's very obvious to see what's going on. And if we just subtract those two, we can clearly see that all the recurring decimals will disappear. So 99y is equal to 22.5. So y is equal to 22.5 over 99. Now we're adding those two things together. That's why I'm not actually fixing this issue with the whole 22.5, because I can actually add them straight away because they have the same denominator to get 37.5 over 99. Now we have to try and get it down to 66. So yeah, that's a little bit funky, isn't it? I would probably just times by 10. Let's times by 10 to make it 375 over 990. Divide top and bottom by 5 gives us, well, I mean, let's work it out. 0, that'd be 7 raised to 2. 75 over 990. We could also just divide by 10 and double it in order to get that. So we do 99 times 2, which is 198. What else could we divide by? We could divide by 3, if I'm not mistaken. Yeah, divide by 3. We get 25 over the 66 that we want. Because 66, 132, 198. That's our final answer for 3 marks. A little bit harsh, but, you know, it's stuff, right? This question's fun. So we have ABC, and so this small triangle here and DAB are 2 similar isosceles triangles. And they give us the ratio of BC to CD is 4 to 21. So we have 4, 21, which means the entire length BD is 25. Find the ratio of AB to AD. So we need to work out the sides AD and AB. Cool. The first thing is these 2 sides are equal because it's an isosceles triangle, right? Where it says ABC. So those 2 sides must be equal. But we also know that AD and BD are the same length. So it's also 25. Why? Because it's an isosceles triangle, right? So this whole triangle here is also isosceles. So this is from B to D is 25. A to D is also 25. Now, we need to work out AB. Now, if it's an isosceles triangle, it means we can split it down the middle, which means that length, these lengths are both 2. What we're going to do is we're going to work out the height here and then work out A to B using that. How can we work out the height here? Well, this makes a big right angle triangle. So if I draw out what we have, this is point C, that's point D, that's point A. We're going to work out the height here. This length is going to be the 25 minus the 2 that I've cut off. So it's going to be 23, and that's going to be 25. Now, here's the fun bit. H is going to equal square root 25 squared minus 23 squared, which is not easy by any means necessary. But when you do that, you do get square root 96. The reason why I know that, by the way, is when you do A-level maths and mechanics, they have a lot of these similar right angle triangles that you end up doing. But again, you could work that out just using your brain, right? Now, what we can do is we can use Pythagoras again, because if we look at the other triangle that we've made, that length is 2, the height is square root 96, and we're working out AB. So the length AB is going to be square root 2 squared plus 96, right? Because it's root 96 squared. So that's going to be square root 100, which is 10. So we have our sides now, right? We have 10 and 25. So AB to AD is 10 to 25. Divide both sides by 5, we get 2 to 5, which is our final answer for 3 marks. That is not an easy question. It involves a lot of breaking down. Yeah, I reckon you could at least get 1 mark for doing for working out the lengths of these two sides, but finding an AB is actually pretty tricky. For this question, it's a bit disguised, but it is an indices question. So we're going to simplify both of these things in terms of indices, and then use the fact that x plus y equals 8 to work out our value. So first of all, how can we write this? Well, we have 2 to the power of x equals 2 to the power of n. I'm happy with that. Over, how can you write the cube root of 2? Well, you'd write it as 2 to the power of 1 over 3, which means that I can combine this. What happens when you divide two bases? You make it a subtraction. So 2 to the power of n minus a third equals 2 to the power of x, which means x is equal to n minus a third. Because remember, both sides of these should be equal. Now if we look at the 2 to the power of y, we can do the same thing. That's the square root of 2 to the power of 5. So how do you write the square root of 2? You write 2 to the power of a half to the power of 5. What happens when you have a power to the power, so a bracket like this? You multiply. So that's to the power of 5 over 2, which means y is equal to 5 over 2. Because they're saying x plus y is 8, we can sub in our value of x and y. We have n minus a third plus 5 over 2 equals 8. Because again, y is 5 over 2, x is n minus a third. So let's simplify this. Okay, we need to combine those two. So if we make them both out of 6, for example, that would be 2 out of 6 plus, we times that one by 3, we have 15 over 6 equals 8. So that means n plus 13 over 6 equals 8. So move it over to the other side. 8 minus 13 over 6. Can I check? Do we need to give it? It just says the value. Okay. So combining this, that can be over 1. So we need to times it by 6. 8 times 6 is 48. Which equals 35 over 6 as our final answer. Not too bad, but that is a very weird indice question. I have actually found a super hard indice question that I was doing in intervention with someone else's class that I'm tempted to go through because that looked pretty crazy. So let me know in the comments if you want to see something like that. Yeah, another fun question, capital F. We have a solid cuboid, okay, it has a volume of 300 centimeters cubed. It has a total surface area of 370. The length is 20, The width is good, blah, 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 blah. Cool. So it says the width is greater than the height. So we're going to have a cuboid that looks something like this. I always mess up the back. Always the back side. It always is. Right, so it says the length. Now, it depends on what you want to consider the length. It really doesn't make a difference. Let's just say that's 20. And then the width and the height we don't know. Let's call them x and y. Now, we have to work out the height, so we have to work out y. Fine, happy with that. Well, first of all, the volume is 300, so let's just write that out. That would be, how do you work out the volume of a cuboid? You times all the sides together. So x, y times 20, so 20xy equals 300. So divide both sides by 20, you get xy equals 15. Okay, that's something. We might be able to use that in a minute. What about surface area? Oh, I love surface area. Well, the surface area is going to be the 6 faces, the areas of them all added up. So let's work that out, shall we? So with the surface area, we're going to have 2 times the front face, because the front and back of a cuboid are the same. So we're going to have 2 times xy. Then let's do the left and right side. So that is a y times 20 rectangle. So, but again, there's 2 of them. Right, because again, the front is a rectangle like this. The side is a rectangle like this. And then we have the top and the bottom, which are rectangles that are x wide and 20 deep. And we have 2 of them. And that should all add up to 370. So let's simplify this briefly. We've got 2xy plus 40y plus 40x equals 370. I'm going to divide everything by 2, so we get xy plus 20y plus 20x equals 195? No, 185. Because 85 times 2 is 170. 100 times 2 is 200. Good. Alright. Now we need to solve it. Okay. Well, we want to work out the height, which is y. So what I want to do is I want to eliminate x from this equation. Okay. I could rearrange this equation for x. So that gives me x is equal to 15 over y. Let's sub that in. So we have 15 over y times y plus 20y plus 20, 15 over y equals 185. So those y's there cancel. That's still 20y plus 20 times 15, that would be 300 over y equals 185. This is actually a quadratic. So if you look, if I times everything by y, we get 15y plus 20y squared, quadratic, 300 equals 185y. Let's move everything to the left-hand side. So we get 20y squared plus 15y. No, we don't. We get 15y minus 185y. So that'd be minus 170y. Plus 300 equals 0. Now I can't divide them all by 20, but I can divide them all by 10. So we get 2y squared minus 17y plus 30 equals 0. Just double checking. Yeah. Then all we need to do is solve this. Now for solving it, a few things you could do. I would say factorize might be the best way to do it. And depending on how you factorize, you have a few different options. Yeah, okay. I'm going to do the long way of factorizing just because I think most people would be familiar with it. So it needs to be times to 60 because you have to do the number in front of y squared times the number in front of at the end. So 2 times 30 is 60. It needs to add to minus 17. So of course we're going to use minus 20 and 3. So 2y squared minus 20y plus 3y plus 30 equals 0. Break it down the middle. Factorise out 2y from the first two terms. Actually, we want to make that a negative, don't we? Yeah, we'd have to make that a negative in order to make sure it works properly. Ah, I see. So back here, it needs to times to 60, so it'd be minus 12 and minus 5. Good thing I spotted that, because otherwise it would have been impossible. Again, if you notice when I spotted that earlier, the way I spotted that is I realised that I wouldn't be able to factorise and get the same brackets. Y minus 6 minus 5, y minus 6 equals 0. So we either get 2y minus 5 as our brackets, and we get y minus 6 is the other bracket. So we get two values, and we have one is y is 2.5, the other one is y equals 6. Now it tells me that the width is greater than the height. So if we have two answers, 2.5 and 6, then the smaller answer should be the one that we use. So y is equal to 2.5 for 5 marks. Nice and easy. Okay, so sketching the sine graph, I'm willing to bet a lot of you guys know how to do, but doing this solving for this is like year 12 trig. It's kind of interesting. But for the sine graph, it starts at 0 and it goes between 1 and minus 1. And every 90 degrees something happens. So 90 degrees it goes up to 1, another 90 it goes back down to 0, another 90 it goes down to minus 1, another 90 it goes back up to 360. Cool. Now it says here, solve the equation 2 sine x equals minus 1 between 0 and 360. So that means sine x equals negative a half. If I look at minus a half on this graph, we get that value. As you can see, between 0 and 360, it intersects twice. Now the only thing that we have to do is figure out what that's going to be. Now, I'm not sure if you'd know this. I hope you do. But for sine of a half, you might know that the value is 30 degrees. So the distance between 0 and 30 when it goes up to a half is 30 degrees. That means from here, going from 0 to minus a half is the same as going from 0 to plus a half. So that's an additional 30 degrees. Same thing over here. Going from minus a half to 0 is the same as going from 0 to a half, because this graph is symmetrical. So it'll be 360 minus 30, which is 330 degrees. Those are the two values. It relies entirely on the symmetry of the graph. So you do need to know that every 30, well, going to or from a half or minus a half is always 30 degrees. Always. Let's move on to the final question. And here we are at the final boss, the final question, which is of course a line and a circle, because why wouldn't it be circle geometry, right? It's always circle geometry. Everything's circle geometry. So I always find it useful to draw out a little diagram for this. And we have a circle that is centered on the origin. You know what? It's close enough, right? Give me a break. Then, the line intersects at points P and Q. Now the important thing here is it's not a tangent because it crosses at two different points. So I'm going to draw the line going something like, I don't know, like this. Okay? And we have points P and Q. P is 5, 10, so let's just say that's there. And the x-coordinate of Q is minus 2, so this point here, Q is minus 2. Okay. And it tells me that it has a positive gradient. That's how I knew it was going up at a slant. And it crosses the y-axis at point K. So that point there. Find the value of K. So the best way to do this, in my opinion, is because this is a y-intercept, because the x-coordinate is 0, so we can see it's there, then we probably just need to work out the equation of the line for that point. Okay, that's not too bad, because we already have a coordinate on the line. But in order to do this, we actually need to find two different coordinates. Yay, very fun, right? So how do we do that? Well, what I would probably end up doing is using the equation of the circle. If we knew the equation of the circle, we could sub in x as minus 2 to find out what the y coordinate is, right? Because when we have the x value. In general, we have x squared plus y squared equals r squared. So how could we work out the value? Well, the first thing is we don't know what the radius is, so we need to work that out. There are two ways to work it out. We could use the fact that we have a coordinate and just find the length of the line from the origin to there, or we could just sub in a coordinate. So when x is 5, y equals 10. So we have 5 squared plus 10 squared equals r squared. So that's 25 plus 100 equals r squared. So r squared is just equal to 125. There we go. Now we have the radius, right? So what we need to do now is we need to work out what the y coordinate of q is. So at q, x equals minus 2. So we're going to sub that in. We have minus 2 squared plus y squared equals 125. 4 plus y squared equals 125. Y squared equals 121. So y is equal to 11. Now, technically, it's plus or minus 11, right? So which one do you think it's going to be? Well, logically, because this has a positive gradient, it's going upwards, then the y coordinate must be less than 10. Because if it's going up, then the coordinates on the left, for example, k is going to be less than 10. This point is going to be less than 10. This point is going to be less than 10. Right? Because it's going up over time. So points on the left of it should have a lower y value. So we're going to say that y is equal to minus 11. Now this is trivial, we just need to work out the equation of the line. So if we work out the gradient between p and q, so m, qp, we have the change in y, so we have 10 minus minus 11 over 5 minus minus 2. So that is 10 minus minus 11 is 21. 5 minus minus 2 is 7, so the gradient is 3. So if y equals 3x plus c, then if we just sub in one of the coordinates, let's sub in x is 5 and y is 10. Then there we go. That is our value for k. So again, the key parts here, I mean, what are the key tricks here? The first one is working out what the radius is. There's two different ways to do that. The second thing is spotting that this is not a tangent, which means when we sub in any of the coordinates, we're going to find two values, right? Because it intersects twice. The third thing is actually working out, spotting to draw the diagram and what k actually is, which is the y-intercept. So it's not an easy question at all, but hopefully now I've gone through it, it makes a bit more sense. Coordinate geometry or circle geometry, whatever you want to call it, it comes up all the time. And it's a really popular final question for the paper 1. So I wouldn't be surprised if something like this came up this year. It would not surprise me in the slightest. But anyways, we've gone through everything. Hopefully you found the questions that you looked at helpful. Hopefully you can now add up your score and also work out what grade you would have gotten had you done this paper last year. If you did find this useful, please do consider subscribing and sharing this video because it does really help me out. And best of luck with your revision. I'll see you in the next one.